how do we subtract these two fractions? How are we gonna do this? Well, we already know to add or subtract fractions, you need common denominators, right? So let me bring it down here. So we have 9 and 5/12. And then, so we're going to need to multiply top and bottom by 4 there to make into 12. So subtract 2 and 8/12. Is everything good there so far? So we're subtracting and we've made common denominator. That's the step number 1. So step 1, get common denom. Okay, now I've got a problem with this subtraction, don't I? Here's what I've seen in the past some students do. This is wrong. 9 minus 2, people will go 7, and then 5/12, 8/12 is 3/12, and then just reduce that, divide by 3, 7 and a 4th. That's wrong. Why is that wrong?
Because you can't, since 5 is smaller than 8, you need to borrow from the 9 in order for it to be bigger.
Exactly. Yeah, right there. What's wrong with this is yeah, they didn't really take 8/12 from 5/12, right? They reversed it. They took 2 from 9 and then they took 5 from 8. They reversed it. You can't switch which direction, right? You can't take the 5 from the 8 and say, well, it's just 3. You think, yeah, well, it's the smaller one. It doesn't matter. This one's coming first. You've got to take the 8/12 from the 5, don't you? You can't just reverse it because it's more convenient that way. Right, exactly. So the question becomes, how do we take 8/12 from 5/12? We can't really take 8/12 from 5/12, and so we borrow. Yeah, exactly what Martine was saying. We borrow from the 9. 9 becomes 8 and 12/12. That's the same thing as 9, isn't it? That's 8 and 1 more. 8 and 12/12. Why? You might wonder, where'd you get the 12/12? Well, I need to make a 1, and I need to use the same denominator that we already have, the common denominator, which is 12. So I make it 8 and 12/12. That makes sense. I could make it 8 and 3/3, 8 and 4/4, 8 and 5/5. All of those are 8 and 1 more, aren't they? They're all different ways of saying 9, right? Whenever you put the same fraction over itself, that's just a 1, isn't it? So all those are ways of saying 8 and 1 more. In other words, 9. Well, why do I use 12/12? Because that's the denominator in our problem. That's the common denominator we established on step number 1. So that's the common denominator I need to use. So I make it 8 and 12/12. That's just a fancy way of saying 9. It's kind of like taking taking $9 and saying, oh, it's $8 and then some change, right? Turning one of my dollar bills into coins. I still have the same amount of money. I still got my $9. I just have $8 as bills and $1 more in change. That's like what the 12/12 is like. It's like the change. It's $1 in change. It's still $9. So going back to the problem then, what are we going to do? We are going to subtract. Oh, actually, I didn't finish here. 8 and 12. I'm not ready to subtract yet. I need to first finish this problem. First get the borrowing done. All right, so everybody good so far? So this 9 has become 8 and 12/12. That's the same as 9. We didn't lose any money there, right? The $9 has become $8 and then $1 in change. Nothing has been lost. Now I can combine these two to be 8 and 17/12. Everybody see that? 8 and 17/12. That's the same thing, right? I just combined the 12 and the 5 to be 17/12. Now I can subtract, can't I? Step 3. Now take 8/12 from the 17/12. Now I can do it. So I can go 8 minus 2 is 6. 17 minus 8, what is that? 9/12. And one more step, final step, step 4, reduce. So I'm going to divide by 3, top and bottom. And so this will be 6 3/4, and we're done. So there's the whole problem. So that's probably the trickiest thing in this section, having to borrow with mixed numbers. Questions I can answer on that one?